camera now. It's all good. Pants. Pants. All right, my friends. So. If you say the data is not bell-shaped enough, I can live with that. We got tools for that. If you say the data is bell-shaped enough, I can live with that. We got tools for that. We're going to have an in-class quiz we're about to do in 5 minutes. We'll deal with both of those things. So the question I have for you is, depending, no matter what you said, whether you think it's bell-shaped enough or not, how do you pull statistics from the data in this machine? So suppose you say, yes, this is bell-curved enough. I want to know what the center and spread of the ages of the top finishers are. What would you type into the machine to pull those numbers off of? Now on the exam that you're going to do at your house, you're most likely going to use Excel to do this. Because I got everything set up in an Excel spreadsheet and you're good to go and you'll learn how to use Excel. I'm assuming you don't know how to do it already. That's my assumption. So when you go into that Excel spreadsheet and you've got a PDF document to guide you, I'm assuming you've never turned Excel on before, so it'll walk you through it. Hopefully it's that clear for you. But here, we've been doing this quite a bit, but Linda, help me out. What are we going to do? What are we going to do?
So you go to Stat.
I'm going to go to Stat.
You're going to push Calc.
I'm going to push Calc.
And then you're going to say Enter.
I'm going to say Enter.
And then you're going to, oh, my screen came up. I had to change to L1.
Oh, here we go. Here, I'll just do this. Stat, Calc, Enter. There we go.
And then make sure it's on L1.
L1, like this. Sure.
Sure. And then Enter.
And then press Enter.
Oh,
Enter.
error. That's what I got.
Okay, that's what I got.
Why did something wrong?
Does anybody see? Remember, this is the top finishers right now. Does anybody see a problem with this?
It's not what you said in the first time.
Somebody just said it's just doing the age.
It's doing
Tell
the
me your
age,
name.
not the Gail.
Gail, thank you. So in other words, first of all, the TI thinks how many people are in the top of my sample. Can you tell by looking at this? How many people? Yes, Siri, she might know. Sandra, 7. It thinks there are 7 people.
Yes.
Now we know there aren't 7 people. There are more than 7 people, correct?
Right.
But also, here's something else I want to look at. If I look at the graph and I look at my scales, 19 to 88. So we got 19, we got 88. These are about 10 wide-ish, somewhere in that neighborhood. Ish. 49 somewhere over here, which is what the average is telling me it is. If you look at that average, it's telling me it's 49 and a half. That number exists right here. Now, how many of you would balance your finger right there if you were balancing this cookie tray? You wouldn't, would you? And now, perfect. This is where the TI, once again, has a bug. This is one of those things I wish SASAR would fix. But when you have data split across frequency distributions like this, you gotta tell the TI that. And it's a really simple thing to do. You ready? Linda, you brought us exactly where we needed to be. 1 bar stats. Then you typed L1. Perfect. You need to do that. But then you gotta hit a comma, which is directly above the number 7. It's got its own button. That comma button right there. And then guess what you're gonna put after the comma? Take a guess, take a guess. L2, which gives you the frequencies. The 89, you don't have to do this, right, Kev? It's already set up for you, I think, to put list 2 in there if you're gold. Cool?
Mine has a bar. Yeah, my graph does.
Your graph has a bar. Let me see. Oh, you've got something turned on at Y equals. I will turn that off for you. That looked like that was a Math 105 curve. Way back in the day.
Way down.
That was the filtration curve, 13%. So I got 1 bar stats, L1, L2, press enter. Are we looking like this? We're not. We'll fix the problems when we're not. So, let me see that. Oh, I see what you did. You got to type 1 bar stats first, then L1 and L2.
Oh, okay.
Does that make sense? Is that fair? We'll do it again with L1 and L3 here in a second to make sure we get that squared away. So here's what I come up with. First of all, I like that better. 81 is a reasonable number for the people that I surveyed. I mean, if I look at the numbers, there are 44 from 25 to 44, or 25 to 34, and then 19, 10, 1, and 7. That sums up to about 80. I can live with that number. But also, that number, 33.8, or just about 34 years of age, that makes a lot of sense when you look at that graph. Where would you put your hand to balance? Where would you put your hand to balance this tray of cookies, friends?
About there.
Feel free to vote.
Go further.
Further.
There.
Somewhere about here,
Yep.
which is damn close to where 34 years is. That's 19. These are about 10 wide. You got 19 and 29. It's somewhere about in here. You guys are damn close. It's not over here.
Right.
So you've nailed the average, even with a little bit of tail on there. Yes. Yes. We also have a standard deviation, don't we? We got a standard deviation of about 9 years. About 9 years. Fair enough so far? Getting some numbers? Who said the curve was too skewed to use the center on? Hey, that's cool. Scroll down. Whoops, I gotta run it again. Hang on. Scroll down. You guys might want to go with the median of 29 and a half years. Maybe you go with the median of about 30 years. I'm down with that. I could totally live with that. If you say that I would not pair it with a standard deviation at that point. I would just leave the median by itself. Can anybody see why you might not want to pair the standard deviation with the median? This is a tricky question. It's more of a mathy question than a statty question. Why do you, I love pairing these guys together. They should be paired together, actually. But the median, he's on his own, really. You shouldn't tie the S to the median. Anybody know why? It's a mathy question, like I said. Go ahead, tell me your name again, too.
Macy.
Macy, please.
Because the standard deviations talk about the distance from that average.
Nice, Macy, perfect. This is why it's a mathy question. You nailed it, Macy. The standard deviation is the square root of the sum. Don't flip out it just here. Each data point from the average. This is why this guy is paired with him, because he's part of the calculation of this guy. The median's not in here, the average is. Is that fair? That's what's going on in your TI's brain when it spits out that S value, is that calculation right there. You guys look very confused. So the standard deviation can be paired with the average just by what Macy just said. Perfect. So on average, the runners in the top are about 34 years old, plus or minus 9 years. If you say the data's bell curved enough, bell-shaped enough, you can tell me that 68% of them are within 9 years up or down of 34. That's what we did last time, right? If you say it's bell-shaped enough. Up or down 9. 95% will be up or down, how many? 18. Almost all of them should be up or down
30.
27, right? 9 times 3, 27?
Yeah.
See what I'm doing? I'm just going out numbers to standard deviation. Sorry for that face. Upper 9, 18, 27. You can go further, but it gets a little ridiculous at that point because now you're running Yoda and you're running negative numbers. So, fair? Good. Now, let's take some predictions. We know that the average of the top is about 34 years. And that average carries a standard deviation of about 9 years. What do you guys think the average of the bottom is, numerically? You can calculate it, but go for a gut feeling first, all right? Where's the average of the bottom? To the left or to the right of the average of the top? Vote for the right? Second for the right? To the right? Yeah, over here. Good, good. So we think that the average of this one is going to be bigger than 34. That's a prediction. Cool. How about the S value that accompanies that? Do you think it's going to be bigger or smaller than the S value that accompanies the top curve?
Smaller.
What do you think? Vote for smaller? Love it. One vote. Okay. Okay. Let's test it. Let's calculate it and see. Okay, I'm going to erase this. We'll come back to it. So let's rerun the statistics. Second quit. One bar stats again, for sure. One bar stats, for sure. Guess what you're going to put after it this time? Be brave. L1, L3. Andre, go ahead.
Okay, I just can't make it do L1 and L3 because when I try to do the comment, it just does a J and the 37.
Oh, I think I know why. So you got L1.
Yes.
For some reason, your alpha block is on. Just press the alpha button again so the A is not blinking. Now press the comma key and it should work just fine, Andre. Is that working for you now?
Yeah.
Let me come fix it real quick because that's annoying. That's annoying as hell, yeah. Oh, I see why.
I don't see where he's at.
This is frustrating.
You go to your stats, and then
Ow.
and then number 1.
It's that damn button that says our whole thing.
No, go back to the 1.
I'm surprised he hasn't put a restraining order out against me yet, honestly. Honestly, seriously, I'm that guy. Dude.
Oh,
L1, comma L3?
no.
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 This makes sense, I hope. We're using the same data that L2 used. The data is ages. We're just using the frequencies from
Then I
L3
put
now.
my comma in then.
Is that fair? Good. Here we go. I now get an average of about 44 years. The bottom finishers are about 10 years older on average. So guys, nice hypothesizing here. You're basically a bar over from where the other one was.
Oh, right.
That's very good.
So it's go back.
I thought you said you didn't want to round.
Okay.
What's that? No, I didn't want to round in the calculation of the average. Here, I'm just going to the nearest whole year. And that's a very good question. Tell me your name one more time. Caitlin asked a question. I thought you didn't want to round. I'm using all the precision I'm allowed to use because the numbers in this data list by sig figs are whole numbers. So my final result needs to be rounded to whole numbers, theoretically speaking. However, when I was actually doing the calculations up here, if I took those halves and rounded each of them up, these guys would most likely be about 1 year above what they should have been. So in other words, I don't round until the very end of the calculation to the correct number of sig figs. It's a loaded answer, and I always tell you what to round to anyway. Is that fair? What you don't want to do is round intermittently as you're doing a calculation because you get further and further away from the true result. Is that fair, Caitlin? It's a very, very good question. Cool so far? What's the standard deviation? 13 years. It's actually bigger than the other one's standard deviation. Explain that to me. Explain that to me. Let me see hands on this one. This is a non-mathematical, purely statistical question. Let me see hands. Why is that one standard deviation bigger than the others? Let me go ahead.
I just wrote that down.
Because of the 3 and the 2 in the last 2 categories that are making it bigger.
What are you doing? What are you doing with it?
More variance.
Uh-huh. Look at the data set. I'm going to draw a couple curves on top of this one. I'm going to make a smooth bell curve. Top blue, bottom red. If I was to make I'm forcing a bell curve. For those of you that said these aren't bell curves, I apologize. But my argument's going to hold whether or not they're bell curves or not. Is that a fair approximation of the top? Ish. Fair approximation? Is that a fair approximation of the bottom?
Yep,
Which one's wider?
the bottom.
Red, yes, the bottom. If it's a wider curve, that means we got a larger variation within the data. I love what you were doing when you were describing it. Your hands were going out to the side like this. I love that. There's more in the tails, right? It's not as crunched in and high. It's lower and spread out. We had the same discussion in 244 about the t-distribution this morning. It was wonderful. Candace, go.
So this might be kind of a dumb question, but
Nope.
I don't understand why, with the plus or minus, the variations, why are we getting overlapping so much? Like, I
Between the top and the bottom?
don't get it.
You mean the two curves that are the blue and the red?
Yeah, just with the numbers, because now if we go with the standard deviation and we go 44 and we subtract 1 standard deviation and we go 44 minus 13, we're going into the top finishers. It's really confusing me. I'm starting to get really confused.
Quick answer. Well, first of all, don't get confused.
It's because the data overlap.
Let me give you 3 answers.
Okay.
Well, 4 answers. First of all, don't get confused. Data has to overlap, in general. Here's a problem that I have with people that misunderstand data. Not you, I'm not talking about you, I'm talking about, and we're gonna get into this more on Thursday too. So, you go to the pediatrician with your kid. I'm gonna bring this back up on Thursday. And they show you a growth chart, which is based on a bell curve. And let's suppose your kid is off the charts in some measurement. Head girth, that's my favorite measurement, when they measure head girth. Slap a ruler on your kid's head. So what they tell you is something like your kid's in the 105th percentile. And I go, what the hell does that mean? And they say, well, and they try to explain something along the lines of, well, it means that he's now in the curve for the next age group. And I say, you don't actually believe that, do you? And they say, what do you mean? I'm like, well, that's like saying there's some cutoff beyond which a 5-year-old can't go past, and below which a 6-year-old can't go below. Those curves don't look like that. The 5-year-old curve is red. The 6-year-old curve is most likely something like that. Because the shortest 6-year-old is going to be shorter than one of the taller 5-year-olds. I watched a ridiculously sized 7-year-old kick my son's soccer team's ass last Saturday. The kid was like a foot taller than the rest of them, dribbling around. I'm like, who the hell tall is this kid? It's a Pele out there.
And the legs, yeah.
In the legs, right?
Yeah.
So the curves should overlap, Candace. And we're going to learn how to deal with that in this course. I promise you that. And the overlap not only is guaranteed, but it's wickedly important. If you don't have overlap,
Understand the standard deviation yet is what the problem is?
oh no, and I don't expect you to. It's too soon. We're still in the middle of learning about it. Yeah? It's just average distance. Keep that in your mind. It's the average distance. The bigger the standard deviation, the more varied. And I love having two data sets side by side, because then we can say to ourselves, okay, this one's got a bigger standard deviation than that one, therefore it's more varied. And I love being able to see that in graphical ease. And to your fourth answer to your question, which is fantastic, is this enables me to say, on average, the bottom finishers are about 10 years older, with standard deviations, of course, which means that I didn't find support for the theory in this data set that the older runners are finishing. Now, I'm not saying that even proves or disproves anything. I'm just saying that my average didn't help me prove or disprove that. I can't take too much from that other than that, but I can say that the bottom finishers are 10 years older on average. Please, Andrea.
Does the standard deviation apply to margin of error?
So, that's a great question. That was actually a fifth answer I was going to have for yours, kids, and I decided to back up because I figured 4 was enough.
Setting us up for the margin of error.
We are. And the margin of error, we're going to get into the margin of error in 10 minutes in this quiz we're about to hand to you guys. A margin of error is when you take a sample and apply it to a population. We are not doing anything except looking at the sample of the people that I pulled from this marathon. I mean, if I do that plus or minus 9, that only means that 68% of those in the sample are within 9 years of the average. And if I go out 9 more top and bottom, that's 95% of those in the sample. If I want to take that and apply it to all Portland Marathon finishers and or all marathon finishers, that's where the margin of error has to kick in, Andrea. And we haven't even gotten to that yet. I mean, we've gotten to it in that I've had you guys calculate a few, and I'll have you do it again here momentarily, but as soon as you step out of descriptive and make it inferential, that's where you need to use, that's where it becomes a margin of error, and it's tied to that. It's tied to that measurement. And part of this course is developing us to get to that point, where we actually are talking about a standard error and then a margin of error. That's the very last couple of weeks we're together we do that. Probably the best part of the course, in my opinion, it's the best part of the course. Cool? Yeah, I shouldn't say that. It's all pretty damn good. Fair? Other questions? Those were some serious, awesome questions. Really, honestly. I don't expect this to be comfortable right now. Think about it. You learned an average when you were 8, 9, 10 years old. And now you're like, I think I got a pretty good handle on average. You just learned standard deviation like 5 days ago. Give yourself some time. You guys are so hard on yourselves. Some time. Cool? More questions so far? We're good? All right. So, you can put that data set away for a little bit. I think we're at